On this video, we will talk about the area of a trapezoid. So let's get started. Let's start by reviewing some parts of a trapezoid. Well, on the figure on the right hand side, here is what we call the trapezoid. This is a quadrilateral. And now there are names that we give to the sides of this figure. So we'll start by reviewing what is the base of the trapezoid. Well, a trapezoid will always have two bases, which can be seen as BC can be considered one of the bases of the trapezoid, and AD can be considered a second base of the trapezoid. So we start by saying that BC and AD are what we refer to as the bases. The order doesn't really matter, but we usually put the longest side to be B1 and the shorter side to be B2. Now the altitude of a trapezoid, it is going to be a perpendicular line in relation to the base or B1. Which another way of seeing the altitude you can think of this line as also being the height of your trapezoid. Which in this case, let's give it a name. Let's call this point R. So we can say that the altitude of this trapezoid, it is the line segment AR. And very important, the altitude, it's always perpendicular to the base. And when we talk about the bases, notice that here we have two bases, but we refer to the base that we do have here on B1, which in addition, it can be also be seen as perpendicular to B2. Now, what are the legs of a trapezoid? Well, since the top and the bottom are seen as the bases, well, the legs are those sides of the trapezoid, which in this case, we have two legs. We have the leg of AB, which is the left-hand side, and also we have the leg of DC, which is the right-hand side. So any trapezoid will have all this. The trapezoid is made out of four lines. Two of them are called the bases, the top and the bottom. The left and the right are called the legs of the trapezoid. Now, there's one more property about a trapezoid, which is not represented on this figure, but we definitely have to at least state it, and that is what we call the median of a trapezoid. Where one way of seeing the median of a trapezoid, it is the average of the length of the trapezoids. I'm sorry, it is the average leg. The average leg of the trapezoid. But what do we mean by the average leg? See, I'm doing it again. It's not the average leg or the average length. The average length of the trapezoid. Well, length can be seen in terms of the bases. Well, if I add up the upper base and I add the lower base, and if I take the average of those two, I am going to get what we call the medium. And the medium will always be a line that is halfway between those two bases, which in this case, let's represent it with this. Let's call this point S, and let's call this point B. Well, in this figure, the median, which is the average length of the trapezoid, well, we're going to get the upper base, which is AD. I am going to get the lower base, which is BC, and I will divide them by 2. So this line that we have here, which is defined as SB, is what we call the medium. And if you were to find the length of this line segment SB, you will notice that this line segment is the average length of the trapezoid. In other words, if I add up the first base with the second base and I take the average, I will always get the median of that trapezoid. And the last thing to review is that for a trapezoid, both bases are parallel to each other. So therefore, the median, it's also parallel to the other two bases. So this is what we need to review when it comes to the trapezoid. A trapezoid is a parallelogram. It's a quadrilateral. It is a quadrilateral where the upper base is parallel to the lower base. The bases are the top and the bottom, the legs are the left and the right, and the medium is the average length. And the way that we can define it is by adding one base with the other and taking the average of those two. So now that we kind of have reviewed what makes up a trapezoid, let's start by looking at the main idea for today, which is how do I find the area of a trapezoid? Well, the area of the trapezoid can be defined as 1/2 times the height times the first base plus the second base. But why is it that the area is being defined this way? Well, let's prove it. Let's start statement and reason. So why is it that the area of a trapezoid is nothing more than half of the base times base 1 and base 2? Well, let's see why is it that that makes sense. Well, in our proof, let's start with the givens. So all we know is that we have a trapezoid, A, B, C, D, and it has bases B1 and B2. So this is the given. And now I'm going to define the diagonal of this line because we need the diagonal in order to complete our proof. So let's call this diagonal AC. So notice that AC is the diagonal of the trapezoid. And let's call this, it's a line. So let's define it as some kind of auxiliary line, which we're going to use for our proof. And notice that by introducing this line, the diagonal, what we have done is we have created two triangles. So we have created triangle ABC and also triangle ADC. Well, this is just the definition of a triangle. It's just a three-sided figure. And since we're going to talk about the area, because the way that we're going to tackle this is by looking at the area of those triangles. Well, if I want to find the area of the bottom triangle, let me define the height. So let me introduce the line that we're going to be using as a height. So let's assume that this is the height of the bottom triangle. And now to introduce the height of the upper triangle, we're just going to introduce a right angle here. So now we can say that this height is going to represent the height of the bottom triangle, and this length will represent the height of the upper triangle, which is, notice that the upper triangle is a little bit tricky because we want to take a look at the triangle ADC, but we definitely want to use this height. Okay, so even though this H is not inside the triangle, this is still the height of the triangle. So what we have done here is state that H is the height of those both triangles, but also in addition, notice that the H value here, it's also the height of the trapezoid that we want to show the area of. So H is the height of the triangles, and in addition, it is also the height of the trapezoid. So this is just the definition of the height. So now notice that now, if we think back about the trapezoid, the area of the trapezoid can be defined. So notice that the area of, let me use this figure to just represent the trapezoid. The area of the trapezoid ABCD, this can be defined as the area of the lower triangle ABC plus the area of the lower triangle plus the area of the upper triangle. ADC. And this is just angle sum. I'm sorry, not angle sum, but area sum. So let's define the area of those triangles. So here we have the triangle on the left or on the bottom. Let's try to define the area of that triangle. So let's continue with our proof. So let's just finish it up here. So here we have statement and reason. So which number are we on? This is number 6. So let's say that this continues here. So let's start by defining the area of the triangle of ABC. Well, notice that the area of this triangle ABC is definitely 1/2 times the base, which in this case, notice that for this yellow triangle, the base is B1 times the height, where the height is the value of h. Well, this is the definition of the area of the triangle. Now notice that now, if I want to find the area of the second triangle, which let's do this in blue, the area of the second triangle, so the area of triangle ADC, that's still 1/2 times the base. But now notice that for the blue triangle, the base is being defined as B2. So it's 1/2 times B2 times the height, which notice that the height, it is still the same. Even though this height, it's outside the triangle, notice that the length of this height, it's equivalent to the length of this height. So we can still use the same value of h. And again, this is just the definition of the area. So now if we put it all together, we know that the area of the trapezoid ABCD, we define it to be the area of the yellow triangle, which we already know what it is. Notice that here we have the area of the yellow triangle. So that's going to be 1/2 times B1 times h plus the area of the blue triangle, which we already defined the area of the blue triangle here. So that would be plus 1/2 times B2 times h. And all we have done here is we have substitution. Now notice that finally, let's concentrate on this expression. So we have 1/2 times B1 times h plus 1/2 times B2 times h. Well, notice that both expressions, they're all multiplying. So they're all multiplying. So therefore, I can factor out, let me just rewrite it. So therefore, I can now define the area of my trapezoid, ABCD, as just the simplification of this expression. But now coming back to what I was trying to say here is I notice that both expressions has a 1/2 of h in common. So therefore, I can factor it out. And if I factor out 1/2 in h, what is remaining on the first expression? It's a B1. And if I factor out 1/2 in h, what is remaining on the second expression? It's a B2. And notice that this is exactly what we were trying to say. The area of the trapezoid is 1/2 times h times the first base plus the second base, which is exactly what we have just proved here. In other words, any trapezoid can be broken down into two triangles, and the addition of the area of those two triangles is equivalent to the area of the trapezoid. So again, don't just try to just memorize formulas. Try to understand where they come from. Let's just do a couple examples in order to use our result. So now that we know that the area of a trapezoid is equivalent to 1/2 times the height times base 1 plus base 2, let's find the area of some trapezoids. So here we want to find the area of a trapezoid. And all we know is that it has a height of 7 and it has a base of 12 and a base of 2. Well, recall again, this is what we discussed previously, that the area of a trapezoid is defined as this. And let's plug in what we know. Then the area is 1 half times h, which in this case is 7. Oops. We know the value of h, so let's plug it in as 7, times b1, which in this case is 12, plus b2, which in this case is 8. And now at this point, it's just a matter of simplifying. So now this becomes 7 half, 12 plus h, 12 plus 8, that is 20. And now if we continue multiplying this, here we have that the area, you can think of 20 over 1, so 7 times 20, so that's 140. 140 over 2, which this is equivalent to just 70. But again, notice that we're talking about area, so it's not okay for us to just write it out as 70. We need to have the unit square. But now notice that in this example, they were just giving us length. They didn't tell you if it was centimeters, meters, or what kind of a unit we're using here. So therefore, we can just write it as units square. We don't know what's the unit that we're using for the length. So I'm just going to say, well, whatever that unit is unit square. Now, if we compare this to, let's assume that the problem would tell you that this is centimeter squares. So therefore, if this information was given to us, that 7, 12, and 8 were all centimeters, then in that case, we can write it out as centimeters square. But since that was not given to us, so let's just keep it as unit square. But for the most part, they're always going to be giving you some kind of a unit on your problems. So let's just do one more example to find the area of a trapezoid. So let me actually just bring this figure down here. So again, we want to find the area of an isosceles trapezoid. So it's not just a regular trapezoid, but now we want to talk about an isosceles trapezoid. And what do we know about this is that it has legs of a measurement of 5. And remember that the legs are the left and the right. And it has a base of 6 and 10. Well, 6 is the shortest, so therefore 6 is on the top, 10 is on the bottom. But now, since this is what we call an isosceles trapezoid is created whenever the legs are equal to each other. So if one leg is 5, then therefore this leg is 5 as well. So let's recall. So we want to find the area of a trapezoid. So therefore it is 1 half times h, b1 times b2. Let's write down what we know. We know that the value of the first area of the first base is 10, so that's good. We also know the value of the second leg, which is 6, which is fine. So pretty much the only thing that we're missing is the height. So how can we find out the value of the height? Well, in any trapezoid, recall that the height, let me just do this in green. Recall that the height is a line that is perpendicular to the base. So this is what we're looking for, the value of h. So and to be honest, it doesn't really matter if you think about the height as being on the left or the height as being on the right. Like they are both equivalent to each other. Now let's think about this. Since this is an isosceles trapezoid, therefore I can find the value of I can find the value of this line segment here. So let me call this point R, and this line segment here. So let me call this point S, because if the whole base is 10 and A to D is 6, so therefore from here to here, this has a value of 6. Notice that what we have left is 4 units, because 10 minus 6, we have 4 left. But because we have 4 left, and this is an isosceles trapezoid, they must be distributed in proportion. So therefore, this length must be of a value of 2, and this length must be of a value of 2. And this is true because we have an isosceles trapezoid. So now let's think about this for a second. Do we have enough information to find the value of the height? Well, we definitely do now. Because let me just concentrate on this triangle right here. If I concentrate on this triangle right here, notice what we know so far. The first thing that we know is that this is definitely a right triangle, because we do have it here. That was just the definition of the height. This length is h, this length is 5, this length is 2. And since it's a right triangle, then definitely we can use the Pythagorean theorem. So let's do that. So we got 2 squared plus h squared equals 5 squared. So now this becomes 4, just regular 4, plus h squared equals 25. And if we take away 4 on both sides, let's just continue here. So now we have that h squared, it's equivalent to 21. So therefore, h is the square root of 21. So now, let's just write it out here. So now definitely we know the value of the height. And once I know the base 1, base 2, and the height, then I have enough information to define the area. So therefore, the area of this trapezoid is 1/2 times h, which we already found it to be the square root of 21, times b1, which is 10, plus b2, which is 6. So now if we simplify this, we have the square root of 21 over 2, and now 10 and 6, that's 16. So therefore, we have 16 square root of 21 over 2, which notice that this can be simplified as 16 over 2, that's 8. So now this is 8 square root of 21. And again, this is not sufficient. We're just not going to write it as a number. Notice that we need to have some kind of a unit square. But again, notice that in this problem, the units were not given to you. So we're going to just write it out as the numerical value, units square. So this will be the area of my trapezoid. This is just something that we can use our graphing calculator. Which again, if you want to use your graphing calculator, you will get an approximation that the area, if I get 8 and I multiply by the square root of 21, that's approximately 36.6 units square. And again, the reason why we write unit square is because we don't know what's the length of those legs or even the base. So let's assume that the problem was given to you in terms of meters, so 5 meters, 6 meters, 10 meters, then at that point we can say that our final result is 36.6 meters square. But notice that it depends on what the unit. If the unit is given to you in meters, then we write meters square, or else centimeters square if it's given centimeters. But notice that is just something that was not given to us at the beginning of the problem, so that's why we have to write it out in units square. And with this, it concludes our lesson for the area of the trapezoid.